A plastic chip about the size of a credit card could one day diagnose disease in the remotest regions of the developing world.
So using just 1 microliter of whole blood, we were able to get detection of HIV, and we can do that in the field with less volume in about 15 minutes instead of several hours.
The device, dubbed the M-chip by Samuel Sia and his team at Columbia University, is designed to work in places without access to advanced lab facilities.
There's no question, I think, that this type of test is really needed in the developing world and appreciated. But the question is, can we actually develop the test to a point where it can be made available at a sufficiently low cost?
To keep costs low, the M-chip was designed with only 3 simple parts: a plastic tube loaded with blood and chemical reagents, a molded plastic card lined with microchannels, and a syringe that pulls the blood and reagents through the device.
With a team of talented lab mates, we took this exact format to Rwanda, where we did testing on locally collected patient samples. We did testing for both HIV and syphilis. This was a test that could be performed in less than 20 minutes with only a finger prick of whole blood. And we had performance that rivaled that of benchtop laboratory assays.
And the microfluidic design is very simple. It's essentially a straight channel, a linear channel that's been looped around in various ways. And then at different parts of this microfluidic channel, we would have different zones where we would pattern in a molecule that captures what you want to detect.
When whole blood flows into these looped zones, antibodies against disease proteins become trapped.
And then what follows is that you would have washing reagents, secondary antibodies delivered automatically to these detection areas. And then at the end, you have the silver development reagent that develops into solid silver if you have the gold nanoparticles captured on the surface. And so the thickness of the silver film that's formed reflects the amount of analyte that was originally in your sample. And then we simply look at how much light passes through that silver film.
Silver and gold may sound like expensive materials, but the M-chip is actually quite cheap.
The material in making the cassette is just pennies in plastic, and even the reagents, because we use such low volumes, only cost a few pennies. But we think that after packaging it together, it will probably cost a few dollars.
The next step is to take the M-chip into mass production. Sia's team is working with Claros Diagnostics, a company that he co-founded together with Vincent Linder. The ultimate goal is to bring the manufacturing of the M-chip directly to those who need it in the developing world.
We really tried to keep everything as simple as possible. So the control environment which is behind me is actually something which can be moved in any location on short notice, and all the equipment inside of it is off-the-shelf equipment. So we could potentially move the entire facility anywhere in the world on short notice and be able to produce the same quality of material pretty much worldwide.
We have presented one way of integrating different microfluidics technologies together that can be effective in a very resource-limited setting in the most remote regions of the world.
The M-chip is described in the August issue of Nature Medicine.